Research scientist Peter Honeyman and his 4-year-old daughter Margaret at a park in Ann Arbor, Michigan. Honeyman's wife works full-time, and the two of them share duties looking after Margie. But this does not deter Honeyman from working on his projects at the University of Michigan. The university has literally plunged into distributive computing, and Honeyman's adaptation, a cellular phone attached to his laptop, is but one of hundreds of links which have spawned an unofficial motto at the university. No matter where you are, there you are.
It's certainly the case that I can sit down at a computer just about anywhere on campus and have precisely the same computing environment in each one. That's the same Windows system, the same file system, the same applications. What's most important to me is that I could have access to my electronic mail and to the documents that I'm working on, and I have those everywhere. I don't own my own files. I've never even seen the computer that they live on. But I respect and trust the folks that administer the services that I use. It turns out that my files live on a mainframe system about 1.5 miles that way. In fact, it runs under MVS. So I'd say that I have the full line of computing technology here, from the smallest to the very largest.
Honeyman is one of thousands at Michigan connected to the university's Institutional File System, or IFS for short. IFS is how students, faculty, and staff at the school share, store, and retrieve information. This is one of 14 campus computing sites, many of them open 24 hours a day. The sites contain over 1,300 computers. Students use them, among other things, to send email, to submit papers, to communicate with professors, or to work with their classmates on collaborative projects. The bottom line is, the students love it.
I have a theater class, and we have a lot of discussions outside of class, and our whole class got on email under one name, and we just use it to have discussions outside of class.
To talk to someone, you don't have to go physically see them. You can talk to them, and when they get to it, they can write you back. So it's another mode of just meeting with people.
And the meetings go on and on. At U of M, the students are practically wired wherever they are.
In the past, a lot of these students have had to carry diskettes around with them from place to place. Many of these students not only have classes on the central campus, but also on North Campus. The distributed file system allows them to avoid the sneaker net, if you will, of diskette carrying, and store their files on that central distributed file system, so that if they move from a workstation at this central site to another site up on North Campus, for example, they have the ability to just call up their files on that workstation as if they were on any workstation anywhere.
Joseph Mancuso is an engineering student who composes music and stores it digitally on the IFS. He says backup is one key advantage to a musical application in digital distributed computing.
I have a hard copy somewhere available on the network that isn't, subject to, loss of disks or hard drive crashes or, fires or things like that. It's in an entirely separate location to worry about. It's gotten to the point even where, in terms of personal day-to-day files, unless it's something, terribly important that I absolutely have to have on a diskette, I don't even carry disks anymore. Everything is stored on the network.
Mancuso says he can share his digital music with friends on or off campus, even out of state.
A friend of mine who's a student in Buffalo, New York, was working on a piece and sent me the bass line to the piece via IFS. I have it stored in my IFS account right now, and I can access that file from anywhere, and we've worked through that piece together. I was able to listen to his music.
In the past, the computer world has been made up of a lot of different players, all playing their own tune. But in today's competitive world, even companies that march to a different drummer need to be able to band together their data processing operations. Even if the computers are from different vendors or use different operating systems, IBM's distributed computer environment can let different solo computer systems work together in perfect harmony, orchestrating them into a single open systems environment. Traditionally, computers have been independent systems consisting of a central processor connecting to peripherals such as storage units, display monitors, and other input and output devices. Information and messages can be passed between these independent systems as long as they follow preset standards, but the computers still operate as totally separate processors. However, in a distributed computer environment, two or more computers are linked together over a network in a way that allows them to share resources, programs, and devices. Instead of being independent systems, computers work cooperatively. But even though a distributed system can be composed of many different pieces physically located miles apart, to the user, the network and all its hardware and software components appear as a single common system. From a business point of view, distributed computing allows greater flexibility, new choices in the design and data processing operation. Growth and change can occur more naturally based on evolving individual or departmental needs, or the demands of the marketplace, rather than a central imposed plan. Existing investments in equipment and data can be preserved, securely tying together computers that are already in place today to form new enterprise-wide or global systems, while still allowing an organization to embrace new technology as it becomes available. With the new open flexibility, businesses are redesigning processes to drive efficiency and competitive advantage, and businesses are adapting to an international marketplace full of opportunities and the challenge of new and very competitive forces. Often, time to market and quality are the keys to success. Management of well-crafted partnerships and alliances, bringing core competencies together on a project, are used to drive new levels of excellence. At Motorola in Chicago, there is great optimism about the future, while there is great reverence for the past. While the Motorola Museum highlights success over the decades, the future looks bright, and Motorola's Paul Weeks says open systems are part of that equation.
We exist in a very heterogeneous computing environment, which is driven and managed by engineers, which means that we have at least two of everything that have ever been made, and they don't connect to each other. So our challenge is really to find an open system environment that will allow us to separate hardware, software, and communications and make them interoperate irrespective of their source.
And like Motorola, the Statesman's Group looks to its past for the values it brings to its future. That future includes distributed computing, as explained by Dick Brown, president of Statesman's Data Services.
I think the marriage of the mainframe technician with the PC in using computing base, there has to be flexibility instilled into those two worlds, because they need each other, and we're seeing that happen with respect to hardware or technology from that aspect. There needs to be flexibility also in more technicians understanding the in-using business that they're servicing.
In an open world, the University of Michigan is now exploring how the inevitable change we're facing will affect the way we do business. Business psychologist Thomas Finhope says change should be viewed as an opportunity.
I suspect that the battleground disappears, because at that point everyone is on the same page and fighting the common struggle, which is developing an IT environment that supports people's need to do the best work possible. Gives them the access to information resources so that they can do their jobs, the ability to sustain and maintain collaborations with people both locally and globally. And as much as mainframes can be recycled as an element in that effort, I think that puts everybody on the same team, probably for the first time in in years. You know, and the whole history of IT has sort of been a control of a scarce resource by central offices. I think now we've got a mechanism that will really allow those central players to build IT environments that serve everybody's needs. You know, you won't have your mainframe folk versus your distributed folk anymore. We all become information environment folk, and that's got to be a positive development. And an exciting one, too.
The biggest obstacle to implementing distributive computing has been the industry-wide lack of compatibility between systems. The proliferation of central vendor platforms, with their many operating systems, formats, standards, and protocols, have made it virtually impossible for different systems to routinely communicate and share data. This is why the principle of open systems is an integral part of any distributive computing environment. Open systems refers to both a philosophy and a technology for enabling interoperability between different types of computer systems. A distributed computing environment not only allows several individual systems to share data, processors, applications, and devices, and to operate as a single unit, but also allows the individual units that comprise the distributed environment to be on different vendor platforms and running different operating systems. Many of the key players in the computer industry have been working to address the widely recognized need for open systems. A number of these companies, including IBM, plus several research and development organizations, joined together in 1989 to form the Open Software Foundation, a nonprofit partnership whose sole purpose is to make the computer marketplace an open systems environment.
IBM has a variety of mainframe type operating systems, VM and so forth. MVS, the ESA, ESE versions, has acquired the stature as being, this is where you put the company jewels. This is where you put the information that runs your business. And until you've got a technology that can let you integrate with that environment, I don't think you really have an enterprise integration story. You need something that has got an I/O architecture and an operating system design that can lend itself well to large numbers of connections and large amounts of data moving around. Well, MVS has attained almost a mythical stature among the customers that are the targets for this type of enterprise integration. So we look at the tie-in to the enterprise mainframe class systems such as MVS as being the real cornerstone of a successful DCE deployment. So we're very excited to see that coming to fruition.
Suddenly, data which has been stored in the mainframe for years achieves a new system-wide accessibility. Mike Guidry of Phillips Petroleum talks about his company's approach to distributed computing.
We have a tremendous investment, decades of work that have gone into applications that really run our businesses that are sitting on our mainframes. And yet we need to access those applications in a new client-server environment. So we're looking at putting DCE on our MVS platform, and we've been involved with the early customer involvement program and have quite favorably been able to put the DCE on MVS. And one of the things that we wanted to do is to look at, is it possible for me to run a server application on MVS and on Unix, and the client not be able to detect there's a difference between the two? And that was one of our proofs of concepts that we were very successful on. Although we're not a heavy Unix shop, okay, and we're using the opening of MVS to allow us now to very effectively run a distributed computing environment. Yet I think there are quite a few applications out there that now we will be able to bring in to bear on business solutions in an open MVS environment that we really may have questioned bringing them to bear in a pure Unix environment. To some degree, they may feel like the data on their desktop is their data. It doesn't belong to the corporation. There does need to be a much higher level, what we call an IT architecture, okay, that everybody in the corporation can play by.
The open blueprint introduced recently by IBM provides an architectural framework for the enterprise. consultant Dick Boyle says it is an architecture that any vendor can follow.
What this defines is a set of functions that are available. And any system providing those functions can utilize this model. And it doesn't have to be IBM supplied. Thus, it works within Unix. It can work within an MVS. I can put it in VM. OS2. It can run in Windows. So for the first time, what we have defined is a set of functions available across all platforms. And let's face it, that's what we really need. The key part that goes with the blueprint is that it's built on common transport semantics. And that's a mouthful, but it really bases in all communications, makes all communications transparent. So the network is not the system. To the upper layers, the network does not exist, nor do I care. If I took an application and it is built on your model, and it uses your concept of common transport semantics, then it will function exactly the same in the LAN as it would in a wireless environment, as it would in an SNA environment or TCP/IP. So what IBM has delivered is a model that all vendors can work with, a model all companies can work with to define an architecture. And too often we've lost sight that we need architectures. Without architectures, again, technology will pull a company in 10 different ways. With architecture, we focus technology. Today, companies design applications to LANs. And if you do that, then you are going to have a problem and probably face a conversion. You have to focus on things such as DCE that are transparent to communications, transparent to network.
The OSF DCE Distributed Computing Environment is a comprehensive, integrated set of services and tools for open distributed computing. Within the overall systems architecture, all the DCE technology components together form a layer that sits beneath the distributed applications and above the operating system and network communications. The DCE layer supports and facilitates the creation, use, and maintenance of distributed use applications in a heterogeneous computing environment. The DCE technology components are being integrated into that layer of IBM's overall systems architecture dedicated to interprocessor communication. These components, which include a global directory, a security service, a distributed time service, and a remote procedure call facility, combine with existing IBM components and technologies to form a comprehensive and integrated function to handle many different tasks required for distributed computing. Implementing the DCE technology will bring IBM closer to its stated goal of open, interoperable multi-vendor systems. Back at the University of Michigan, campus computing is now about as mobile as this airplane, and that is by design. Ted Hans, who directs the Center for Information Technology Integration, says computing is literally everywhere.
That the term desktop computing will be an anachronism by the end of the decade, because you will compute where you are, because you'll be using productivity applications where you need to apply information. And that means a robust infrastructure that supports the ability for people to physically move from location to location, from spot to spot, and still access their information from desktop devices. Or to be able to carry devices away from the physical networks, but still be able to tap back in a client-server way into the organization's information repositories or applications. And in both environments, a robust infrastructure, a centrally accessible but widely available infrastructure is required for mobile computing, because the data is where the investment is in the organization. So centralizing it under a common administrative umbrella and a common set of policies means that hopefully it's more available, because more people can access it from a central location, and it's more reliable in that it's central custodians of the data. But access and control and all that's still in the user's hands, as it should be. Well, I think that it's important for organizations to carefully consider the advantages they want to seek with open systems and the environment they can move to when MVS opens up. For many, it's a competitive advantage to be able to be more responsive, more flexible, to deal with the changing business conditions. And these kind of technologies enable you to do things in new ways and faster ways than you could before. And especially in a global economy, standards are critical for you to be able to compete around all the corners of the world.
A great leap in open client-server computing, of course, is the new parallel technology from IBM, and the integration of DCE into the Open Edition feature of MVS. This technology will allow widespread sharing of vast libraries of information with the speed and reliability required by the modern enterprise.
I want my head.
By the time Margie Honeyman grows up, it will be a brand new world to explore. And whatever she chooses to do, chances are computers will give her more freedom to do it. In her world, all systems will be working together, anything from her dad's laptop to the largest server. All that makes life better, and that's what client-server is all about.